Hey y'all, this is Mrs. Phipps. I'm going to go over this algebraic kinematics primer rather quickly. The point of it is to get practice looking at a list of variables and choosing the appropriate equation. Now the way this one is set up is that it uses the idea of who cares quantities. Now who cares quantity is, if you think about the video that we saw yesterday, but they say that there were 5 variables, 4 equations, 3 that you need to know to get the last 2, and 1 happy physics student. Okay, so in each one of the equations, there is one variable that is not there. And we use that one that is not there to help us figure out what equation we're going to choose. So going with that, make this a bit bigger. Here are the equations that go with each variable. Now here's our final velocity, the equation that goes with that does not include final velocity. There's only one equation that does not include final velocity, and that is that delta x, let me fix this. Okay, is that delta x is equal to the initial velocity times time plus 1/2 acceleration times time squared. That is the only equation that does not have final velocity in it. I'm going to skip the next one for a second. The next equation, we're going to look for the only equation that does not have time in it. The only equation that does not have time in it is this one. I keep hitting something on accident. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times our change in position. Next one, the only equation that does not have delta x in it is that final velocity is equal to initial velocity plus acceleration times time. Those of you who are very eagle-eyed will note that this is actually our acceleration equation. If you were to rearrange it, you would get acceleration is equal to final minus initial divided by time. And finally, we have our acceleration variable. Only equation that does not have this is basically a rewrite of our average velocity. It's delta x is equal to 1/2 times initial velocity plus final velocity times time. So each of those 4 equations, there's only one variable that does not exist. Now here's the one that I haven't given an equation yet. This variable and the equation that goes with it were not used by our flipping physics person. There is a 5th equation. It's kind of, most people don't really use it, but it does kind of fall on the list, and it helps with this entire idea of the who cares quantity. So that equation that does not have the initial velocity is this. Displacement is equal to final velocity times time minus 1/2 acceleration times time squared. Yes, these two are very, very similar. The difference being one uses initial velocity, this one uses initial velocity, this one uses final, also the plus and the minus. So there you go. But that's basically the equations, and for each one there's one variable that is not there. That's how we're going to do these problems. We're going to look at the list. We're going to see what list of variables, which variable is not in that list. And we're going to use that one, the who cares variable, to choose the equation for each scenario. Okay. We're going to go through A, B, and C. We'll do A, B, and C together. So let me just kind of rearrange some spacing issues. Mostly. Okay, all right, here we go. So here is our first one. On A, again, we are going to look at the list of variables, figure out which variable is not in that list, and use that to choose our equation. So on A, we have the initial velocity. That initial, excuse me here. Get this back where it needs to be. All right, we have the initial velocity. We have the final velocity, we have acceleration, and we have time. The only variable that's not being used is delta x. So that means that the equation must be this one right here. So that's our answer. So it's going to be to solve, given initial, final, and acceleration, find time. To do that, we need to use this equation. That's really how you do it. Let's do a few others together. Erase some stuff here. All right, so on B, we are given our displacement. There we go. We're given our acceleration. We're given time. They want us to find final velocity. Okay. Now in a problem, you would see this, and each of these would have numbers, and the VO would not have a number. If that is the case, that's still part of it. You're looking for the variable that's not mentioned at all. The only variable that is not mentioned is final velocity, which means this is the equation we want to use. So if we're going to solve anything, it's going to include delta x is equal to VOT plus 1/2 acceleration times time squared. Give me 1 second here. I needed to move my shiny happy face so that we could look at that last C problem together. Let me erase just a little bit. All right, get rid of this, and this. We'll try again. So in C, we are given the displacement, we're given the final velocity, the time, and we're looking for initial. So that's displacement, final, time, we're looking for initial, which means the only variable not used is acceleration. So this is the equation that must be used. Delta x is equal to 1/2, see if I can get right enough in here, initial plus final velocities times time. And that's how you do the front half of this page. If you look at it, you got 9 more problems. Really quick, let's go look at the back part of this and just go over it briefly. On the back, number 3, you're going to do mostly the same thing. You're going to choose the equation. And the only thing different is that you are going to rearrange it. Being weird. Is you are going to, once you get it, you're going to rearrange it for the, there it is, there's my letters coming in. You're going to rearrange it. So that's what you do for number 3. Your example is over here on the right. Number 4, there's one problem and you're going to run through it. You're going to choose your variables, write your variables, choose your equation, rearrange, and solve. That's what, hang on. That's what number 4 is. You're just going to do all the work with it. Okay? So here is our video. It's a little bit longer than I wanted just because, well, practice, my first time doing one using this one. So there you go. Have a great evening, guys.